What's up, guys? Here we go, section 4, chapter 2, and in this section what we're going to talk about is many things, but in this particular video we're going to talk about how do you use algebraic properties, specifically the addition property, in geometric proofs. So these algebraic properties are evolving now into geometric properties. So let's rock and roll and let's dive into what addition property is. On your foldable you can write this. Okay, so on your foldable, there's a bunch of flaps, but here's the scoop. This is going to be the one that we talked about in this video that's going to be probably the most amount of writing. So let's put it down here in the very bottom. Let's put addition, the addition properties. So, all the theorems that we get in this video go in this section. So remember, put your finger right here on the addition properties flap and grab a hold of everything else right here and flip it up. And then you have all of that space to write down all the examples that I give you here, the proof that I go over, and anything else that you want to write down to help you master the addition property. So let's dive into this addition property. Let's go. Okay, so you see an example here that you should draw into your foldable addition properties on the addition property flap. A simple little segment here from A to D. And notice what I put in here. What is that word? Notice what I put here already. I've given you information that AB, this segment right here, is congruent to segment CD. Now, my question to you would be, is there anything else that we could conclude? Are there any other segments here that we could conclude are congruent? You would say, not sure. Well, here's how it goes. If you look at segment AB, I'll make this up. Let's say it's, I don't know, 7 centimeters, whatever. If AB is 7 centimeters, and since these two things are congruent, then that means CD has to also be 7 centimeters. They're congruent. Now, what could we conclude about the length from A to C compared to the length from B to D? Do you think there is anything we can conclude? And I would say, you betcha. Because listen, let's say for example maybe BC is 2 centimeters. If BC is 2 centimeters, then that means if I add together, hence addition property, if I add together 7 and 2, that would make AC 9. If I add together 2 and 7, that would make BD also 9. So you could conclude that these two segments right here would be congruent. Now, does it matter? Wait a minute. Let me change this to like 12. If that's 12, and I know this isn't drawn to scale now, but if BC happened to be 12, then the distance from A to C happens to be 19 because of addition, if I add these two together. And BD happens to be the same distance too, because if I add these two things together, that gives me 19. So I propose to you that it doesn't matter at all. It doesn't matter at all what this segment length is here, and it even doesn't even matter what CD and AB are. But if you take, by the way, here is your first theorem for this particular foldable, I guess, for addition properties. It says the following. If I take a segment, one particular segment, and I add it to two congruent segments, then their additions, then their sums are actually congruent. So there is your first theorem. You take one thing and add it to two existing congruent things. That makes bigger things that are congruent. So awesome. Now, does it work? This is segments, of course. So does it work with angles? Well, let's go down here and check this out. So draw this example, I guess, in your, what do you call it? Foldable, yeah. So here's a nice little triangle. You got two different things that's given to you here with angles. Check this out. Angle SPM, that's this angle, is congruent to angle SNT, that's this angle. So those two things are congruent. And you got this. You got angle MPN, that's this angle right here. They're congruent. And angle MNP, that's not right. This actually should say T, sorry. This should say TNP. So this guy right here, TNP. Beautiful. So those two things are congruent. Now, what do you think we could conclude in this picture? Well, let's talk about this again. Let's say that this pink angle right here happens to be, I don't know, I'll make it up, 30 degrees. That means this one's 30 degrees because they're congruent. It was given to me. What if I have this then? These two things, the blue angles, I can't make them 30 because notice I don't have the same tick marks here, so they could be. This whole angle TPN could be bisected, but I don't know that. So let's make it different. Let's make it 25, whatever. So let's say that this is 25. That means this is 25 degrees. So here's my proposal. what could we conclude about angle, I don't know, SPN, comparing it to angle SNP? And yes, I agree with you. These two would absolutely be congruent because if you add together, hence the addition property, if you add this guy to that guy, that would give you an angle of 55 degrees. Same thing over here. If I take 25 and 30 and add them together, that gives me 55 degrees. So here comes your next theorem. If you take two congruent things, whether they be angles or segments, it doesn't matter. If you take two congruent things and add them to two more congruent things, then that makes bigger things congruent. So here's another, I don't know, maybe an example that we could go with. So if you think of a weightlifting guy or person, girl, whatever, like this, where you have a bar that has weights on it, and it doesn't matter what, what the weights are. I don't know, I'll make this up again. Let's say like over here, I don't even know if this is good or not, but I'll just make it up. Let's say that he's lifting 100 pounds over here and then 100 pounds over here. I know some of you are like, that's nothing. Some of you are like, whoa, that's a lot of weight. I have no idea, just making it up. So if he starts with 100 pounds on the left and 100 pounds on the right, they're congruent. You want them to be the same weight, because if not, man, you are in trouble. It's going to be hard, especially people that bench press. If they're not the same weight, look out, man. They need to be the same. But if I'm going to then all of a sudden on the right side add a 25-pound weight, listen, I'm going to have to make sure I have 25 pounds on this side too, but here's the scoop. If I add the same weight on the left to the same weight in the right, so AKA, those two things are actually congruent, and I add them to already existing congruent things, well, first of all, my result's certainly going to be bigger. So this is 125, and then, of course, this is 125. I have no idea, by the way, over here, why I put plus. But these two things, adding two congruent things to two congruent things, makes it bigger, yes, but it does make them congruent. So that's cool. There's a simple example, but it should make sense when you're adding things together. As long as they're congruent, add congruent, add congruent, add congruent, it makes bigger, just congruent things. Alright, it is now proof time. Oh yeah, so write this example down into your foldable right there. Might as well pause this video for sure, because there's a lot to write down. So here we go. Let's prove this bad boy, and here's my tick marks. And you need to get very good at doing this too. I haven't stressed this too much yet, but you need to start it, because there's going to be a lot of things that's given to you, and you need to use tick marks to help you see what's happening. So let's say that we know this. ST and SM are congruent. So I'll put a tick mark on ST, a tick mark on SM. And let's say that we also know that TP and MN are congruent, those segments. So that's this and this. And what we're concluding over here, you see, is that SP, this whole entire thing, that segment, is congruent to SN. Wow. Well, how can we do that? Well, the first thing that I notice is that I'm trying to conclude something that's actually bigger than the pieces that I already have are congruent. That would indicate to me something like an addition property or maybe even a multiplication property, which we didn't talk about yet, but we'll get to that. So, well, this is a very simple, straightforward proof, because my second step would be this. Since I know I have two congruent things, the blue tick marks, and I have two more congruent things, these orange tick marks, it's exactly like the weightlifting example I just told you. I start with 100 pounds, congruent, congruent. I add 25 on the right, 25 on the left. That makes a bigger congruent thing, a bigger thing that's congruent to another bigger thing. So that means my conclusion would be what I'm trying to prove. SP is congruent to SN. Bam. And here is my reason. If two congruent segments are added to two congruent segments, then they are congruent. Then the sums, then the, actually put that, then, whoops, then the sums are congruent. Beautiful. Now, you're going to see this many times in class. I am okay that you write all of this out. That is the exact addition property, and you need to memorize them. All of the four addition property theorems I just gave you, you need to memorize them. But you can really just put this for step number 2. The reason you could have just written this. Whoa. That's right. You can just write addition property. I'm cool with that. I am really cool with that. You'll see that a bunch of times in your book too. Especially when we get to proofs that take a lot more steps than just two, you're going to appreciate the fact that you can consolidate this thing and just write addition property. But for now, let's get very good at writing this and memorizing what these actual addition properties are. So there you go. Addition property. You take one thing and add it to already two existing congruent things, whether they be segments or angles. Or you take two congruent things, add them to already existing congruent things. Those pieces are congruent too. That's the addition property. Rock and roll. Practice this in class. Later.